Hi, Assalamualaikum. My name is Phyton and I am going to start off with the introduction. So, Delivereat is a prominent food delivery service in Penang, seeks operational enhancements for improved efficiency. So, in Penang, we do not only have GrabFood or Foodpanda, but we also have Delivereat as a food delivery service company in Penang. Delivereat prioritizes rapid and cost-effective deliveries by meticulously choosing the shortest and most fuel-efficient routes. So the optimization strategy is to optimize route planning to ensure both minimal travel distance and prompt and efficient deliveries for customers. And the route planning consideration is optimized resource utilization by determining the optimal number of vehicles, their capacities, and strategically assigning delivery locations for efficient operations.
Hi, I am Danisha Sufia binti Muhammad Nur Hisham. Now I will share the problem statement of our project. First, the food delivery service provided by Delivereat in Penang faces the challenge of developing an optimized routing strategy. The main goal is to optimize Delivereat's delivery routes, minimize the total distance covered by the delivery vehicle while adhering to the capacity limits of each vehicle. The second problem statement is about the environmental and cost impact. By identifying the optimal routes, the company aims to reduce fuel consumption, lower vehicle maintenance costs, and minimize the environmental footprint of the food delivery service. Lastly, the organization requires an optimized routine for efficient, secure, and timely food deliveries, crucial for improved operational efficiency and heightened customer satisfaction.
Alright, so we have three objectives. The first one is to create delivery routes that guarantee the number of food orders picked up at each location aligns with the capacity of each vehicle. So this is to ensure that the food transportation is secure and efficient. So the second one is to identify the most optimal routes for multiple delivery vehicles to visit various locations with the minimum total distance travel and also minimum cost of fuel. And lastly is to prioritize the secure and timely delivery of food orders, adhering to traffic regulations and ensuring on-time arrival at the customer's location.
In this project, we use Google Maps for data collection. We choose Penang as the operational region for Delivereat Sdn Bhd to tackle the food delivery optimization problem. There are 17 locations, including one depot, which is Delivereat Sdn Bhd, 8 restaurants and 8 customers. All the 17 locations are marked on the map.
So these are the delivery location together with coordinates, labels and distance. So the first table has the address and coordinates of 17 locations that we have chose to be a part of the project. So that includes the office, 8 location of restaurants and 8 location of customers. And we also include together the label that we use to refer to the nodes and also the label that we use to refer in the coding. So the second table is the pickup route table from one node to another node that have been generated using random choice coding in Phyton. Also the distance for each pickup route. So the rest of the distance will be displayed in the adjacency metric.
To enhance the efficiency of the food delivery, the company should utilize 4 delivery vehicles. According to a research, on average, a motorcycle can cover a distance of 15 to 17 kilometers on a single liter of petrol. So, for every meter of route distance, the motorcycle consumes approximately 0.0006667 liters of fuel. The current cost of fuel per liter in Malaysia stands at RM2.05. Hence, the formula for fuel cost can be calculated using the formula fuel cost equal to route distance times 0.0000667 times RM2.05.
Alright, so this is the adjacency metric that holds the distance between one node to another node. So we have 17 nodes in total, that's why we have from A to Q, And from one node to another node, there will be a distance between it. So for example, from A to B, the distance is 142 meters. From A to C, the distance is 580 meters, and so on. So this adjacency matrix will be used in the coding for Python to generate the optimized route later on.
Next, we move to the source code using vehicle routing with pickups and deliveries by Python Google OR tools to calculate the reduced fuel cost and minimize the overall travel distance. First thing, look at the first picture. We enter the data of restaurants and customers and use a random choice to generate the sets randomly. After that, we use the print command to display the output. For the second picture, we use the coding in that picture to install our tools, and for the third picture, we test the tools after the installation to ensure that there is no error. Next, the data of the distance matrix is entered. Now, look at the picture number 4. We enter the data and we use print command to print the results. On the fifth picture, we calculate the fuel cost and print the total distance of all routes. For picture number 6, we create the routing, and on the seventh picture, we convert the routing variable to distance matrix, add the distance constraints, and define the transportation request. On picture number 8, we solve the problem and we use the print command to print the solution. Lastly, the picture number 9 shows the result of using vehicle routing problem.
So this is the network graph that has been generated using Python in Google Colab to visualize the possible routes of each nodes for 17 locations, all 17 locations, including the office of Delivereat in Penang. So referring to the output from Google Colab, so the first route for the first vehicle is from A to B, B to C, C to N to O, and O is going back to the office, which is A. So the total distance of the route is 1,763 meters with the fuel cost of 24 cents. So here is the graph for the second route for vehicle number 2. So vehicle number 2 moves from A to J to K, K to F, F to G, G to H, H to I, and I is going back to A, which is the office. So the distance of the route is 2,728 meters with the fuel cost of 37 cents. Okay, so this graph represents the route for vehicle number 3, where vehicle number 3 moves from A to P, P to L, L to M to Q, and Q is going back to the office, which is A. So the total distance of the route is 2,357 meters with the fuel cost of 32 cents. And lastly is the route for vehicle number 4, where vehicle number 4 moves from A, which is the office, to D, and D to E, and E is going back to A, which is the office. So the total distance of the route is 2,423 meters with the fuel cost of 33 cents.
For conclusion, the crucial optimization goes through meticulous route planning, minimize travel distance, considers time constraints, and optimize vehicle capacities. This includes all the achieved objectives, which are lower fuel consumption, reduce vehicle maintenance expenses, and lessen environmental footprint, while guaranteeing the secure and punctual delivery of food order. The application of the optimization by the 4 vehicles efficiently distributed delivery tasks across various locations. For the vehicle performance, Vehicle 0 covered locations 1, 2, 13 and 14 with total distance of 1,763 meters and fuel cost of Rm24 cent. Vehicle 1 navigated locations 9, 10, 5, 6, 7 and 8 with 2,728 meters and a fuel cost of Rm37 cent. Vehicle 2 optimally covered locations 15, 11, 12 and 16 with a total distance of 2,357 meters and a fuel cost of Rm32 cent. Lastly, Vehicle 3 covered locations 3 and 4 with 2,423 meters and a fuel cost of Rm33 cents. Therefore, the optimization not only improved delivery efficiency but also minimized fuel consumption, contributing to overall cost effectiveness and operational efficiency for Delivereat.